Pointers and references. Pointers are variables to point to another variables, whereas references are alias for a variable. I will explain it through the editor. Here, let me type it pointers and references. As I told you, it is a pointer is it points to another variable. Essentially, this is a pointer is a variable, and when I say points to, it does this pointing operation by storing the address. Address of another variable. So now you have, if you have a variable which is storing the address, then actually that variable is pointing to another variable. Let's see how it does it. Suppose I have integer type variable x equals and initialized to value 78, and I can create a pointer using this syntax, and I can give the name of the pointer IPTR integer pointer. Then I can set address of x. I can assign address of x to it. So now at this point IPTR is a pointer pointing to variable x. You can access the content of x through the pointer using something called dereferencing. You can do dereferencing by putting asterisks in the front of before the name of the pointer. And if you want to you can access to copy data into it or to read the data from it. So this way you can copy data into the x, not to the pointer, right? So and you can display data by putting this dereferenced expression into the cout statement. And now let me, and also you cannot use this integer pointer to point to another type object. For example, if I have a double object, I cannot make IPTR point to double object. This will be a syntactic error. I need to create a double type pointer to point to this double type object. Then I can make it point to double type object y. But I can use this dptr to point to another object again, another double type object, such as suppose I have two double type objects. Then afterwards I can use same dptr to point to double type object. So you can reassign the pointer to different addresses. You can also use a pointer to point to an element of an array. If I have an integer array of, let's say, 5 elements which are initialized to the values 9, 8, 7, 5, 6, and I can make this integer pointer point to the first element of this array. The name of the array itself is the address of the first element, so you can just copy address, or you can be more explicit. You get access access the first element and put this ampersand operator to get the address of that element. Now you can do the iteration to access these elements. 5 I plus plus, and what is the problem? is okay. And you can put out, let me see, let me call this IARR, I IPTR, and you need to increment it in order to access the different elements. I will actually control the index of the element. So if I is 0, it will be actually pointing to this pointer. I mean I plus 1, I plus IPTR plus 0 will be pointing to this first element. IPTR plus 1 will be pointing to second element, and so on and so forth. So you dereference, that means you are accessing different elements in different iteration. And display in different lines. So this will actually this is one of the use of the pointer. The pointer. Now I'm not going to compile and run. I think this code is work, but my focus is to compare this with the reference. So let me talk about reference here. Reference is just alias or pseudonym for a variable, and it allows like in the case of pointer, it allows access to the data for writing and reading both. But before that, you can you can define a reference for, let's say, for this variable x using this syntax. You have int keyword followed by ampersand, and then you give name of the reference. Let's say IREF, integer reference, and then you make it refer to x immediately. You cannot do it afterwards. You need to do this, you need to equate to the variable you want to refer to at the point of its creation. So it has to be done at this point. If I remove this, compiler will actually flag an error. X. Now through the IREF, you can set the data, you can access the data for writing 78 87, and you can also access I cannot use variable z because it is already used here. So let me use let me give the use the w as the name of the integer variable, and copy the data from IREF. So this is the syntax you can use. So you can, syntax is a pretty easy, straightforward, but in the case of pointer, it is a little bit complicated. You need to get the address, you need to dereference, and those things. Now let me compare the reference and pointer. They are kind of similar in some way, they are different in other ways. So comparison. The similarity is both both provide a way to indirectly access the variable. So if you use x, name x, then that will be that will amount to direct access to the variable. But you are not using x, you are using the reference or pointer, so that is indirect access to the variable. Another the difference here is the reference must be set at the time of creation. But in the case of a pointer, it can be set afterwards. Like in this case, you can create a pointer first, and you can set it afterwards. But in the case of reference, you cannot do that. You can create an iref. This is a syntactic error. So you must set at the time of creation. This is the difference. Another difference here is uh, uh, the reference cannot be set to some sort of null value. Like if you create a reference, you need to set to the valid variable immediately. You cannot set to null value. But in the case of pointer, you can point it to null PTR, IPTR. So this is a null value for this the pointer. So null PTR. This is pointing to null PTR. Now this is another difference. And another third difference here is in the reference, you don't need dereferencing. But in the case of pointer, you need dereferencing. And the final feature, not difference, but feature of reference is that it is usually used in passing objects into functions to avoid the copying of the objects. In the case of pointer, it is used in passing arrays of objects or array of variables. And it is also useful for pretty useful tool for dynamic something called dynamic memory management. So dynamic memory management is the way of actually creating memory and destroying memory during the runtime as required by the program.